Let's solve a basic calculus word problem. Now, I have the word basic here because even if you don't know calculus, as long as you understand some algebra, you'll be able to understand the solution. So do not run away from this video. So here's the actual question. We have two poles that are 30 feet apart from one another. So this is the ground, and maybe these are like telephone poles, and they're also perpendicular to the ground, meaning they form a 90-degree angle here. So the challenge or the question is want to run a wire from the top of this pole down to the ground in some sort of stake. So we're going to go from here to the ground back up to this pole. So we want to use the least amount of wire to make this connection. So it does make a difference where you put your stake in the ground to make this connection. So for example, if you put the stake in the ground right here, we're going to run the wire from here to here back up to here. So the challenge is to figure out where should we put the stake in the ground to use the least amount of wire. So that's what we're trying to do. We're trying to use the least amount of wire to make this connection. So again, here is the information. We have two poles, one 12 feet tall, one 28 feet tall, and they are 30 feet apart from one another. So this is a classic calculus type of word problem. Now, if you know calculus, you can just kind of fast forward to the end of the video and see if you have the right answer. But there is a lot of steps to solve this problem, and I'm just going to take my time and explain things in a nice, easy to understand way. So again, if you don't know calculus, just kind of go along for the ride, get yourself some popcorn, and enjoy how powerful calculus is. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you enjoy this content, make sure to like and subscribe, as that definitely helps me out. So let's see how we're going to use calculus to solve this interesting word problem. So let's get into the solution. And if you don't understand something that I'm going to show you in terms of algebra or geometry, just continue on with the solution. But if you really want to understand calculus or study the subject in a serious way, you'll get a good appreciation in this video of how important algebra and geometry is. You got to have very strong algebra and geometry skills in order to be successful in algebra. But let's go ahead and get started here. So here is our problem. So we have these two poles that are 30 feet apart. And of course, this pole is 28 feet and this pole is 12 feet. So let's just go ahead and run an experiment here just to make sure or satisfy our curiosity that indeed it does make a difference in terms of where we place the stake in the ground in terms of how much wire will be used to make this connection. So let's take this quick experiment. So let's suppose we break up our 30 feet here in terms of 10 feet and 20 feet. So we'll put our stake right here in the ground 10 feet away from this 12-foot pole. So that means this stake is 20 feet away from the base of this pole right here. So how much wire would we have to use in order to make this connection? Well, the important thing to understand here is that we are dealing with right triangles, all right? So this is a 90-degree angle, and anytime you have a right triangle, you can use the Pythagorean theorem, all right? So here, a squared plus b squared is equal to c squared. So hopefully all of you know that, but if you don't know that, this is a simple relationship. So the square of this side plus the square of this side is equal to the square of this side. So here we can determine this length using the Pythagorean theorem. We can also determine this length here because we have the sides of these respective triangles. So let's go ahead and get the actual measurements, and then we'll do another experiment to see if the length, the total length of the wire changes. So here in this small triangle, the sides are 12 and 10, and then in the larger triangle, they are 20 and 28. So let's go ahead and use the Pythagorean theorem to figure out what this side of the triangle is. This is called the hypotenuse, which is the variable c, all right, in the Pythagorean theorem. So hopefully I'm not going too quick for some of you out there. But again, we're trying to figure out the lengths here of the hypotenuse, this side of these triangles, because this side plus this side will be the total amount of wire we'll need to use to make this connection if the stake is in the ground 10 feet away from this 12-foot pole. So let's go ahead and just crunch these numbers. So a squared plus b squared is equal to c squared. So a is 12 squared plus 10 squared. Again, I'm referencing this triangle right here. And then over here we have 20 and 28. We'll do the same thing. So 12 squared plus 10 squared. 12 squared is 12 times 12. That's 144. Plus 10 squared, that's 10 times 10. That's 100. 144 plus 100 is 244. So that is equal to c squared. So to solve this equation for c, all we have to do is take the square root of both sides. And the square root of 244 is approximately 15.6. So that means this wire right here that goes from the top of this 12-foot pole down to the ground at this stake in this location is about 15.6 feet in length. So now we can calculate this length right here using the same approach using the Pythagorean theorem. So we have a squared plus b squared is equal to c squared. So 20 squared, that's 400, 20 times 20, plus 28 squared. 28 squared is 784. So we have 400 plus 784 is 1184, and that's, of course, equal to c squared. So to solve for c, we're going to take the square root of both sides here. So this is going to be approximately 34.4. That's the square root of 1184. So that means that this side right here of this triangle is 34.4. Okay, so how much total wire is that? Well, let's go ahead and take a look at this diagram in this way. So we just simply have to add up 15.6 and the 34.4, excuse me, and we have 50 or 50 feet. So if we place our stake right here 10 feet away from this 12-foot pole, well, we're going to need about 50 feet to make this connection. But can we do better than 50 feet? Does it make a difference? Well, it absolutely does. Let's run another experiment here just to kind of satisfy our curiosity that indeed it does make a difference where we place this stake. So let's place this stake right here 5 feet away from this 28-foot pole. So let's go ahead and do the same method here and calculate the distance. So we're going to use the Pythagorean theorem just to kind of see again that we're going to get different lengths in terms of the wire. So let's just go ahead and crunch the numbers. I'm doing the same thing here. So 12 squared, let me just go back up here because I feel like I'm going a little bit quick. So if this is 5 feet away from this pole and the poles are 30 feet apart, from here to here is 25 feet. So we're going to use the Pythagorean theorem in this triangle, right? So here, this is 12, this is 25, and we'll use the Pythagorean theorem in this triangle, which is 5 and 28. Okay, so again, we're trying to calculate the hypotenuse, and this is the actual length of the wires. So let's go and continue on here. So here is this number crunching. So when we do all this work, we have a squared plus b squared is equal to c squared. You can see all this information. So c over here in this smaller triangle, or the triangle to the left, is approximately 27.7. And then on the triangle to the right, it's approximately 28.4. And you can pause the video to see all this number crunching because we have a lot of work to go. So from here and here, we actually just calculated the lengths. So the total wire here is going to be this plus this. So 27.7 feet plus 28.4 feet, that is 56.1 feet. Now, of course, that is more wire than we used in this situation right here. So again, it does make a difference where we place this stake in the ground in order to get the minimal amount of wire. So now that we understand the problem, let's see some other variables here to kind of make a model of what's going on. So we want to find the length of this wire, right? So here I'm going to use this equation that the length of the wire is equal to y plus z. Now I'm going to use this variable y to represent the length from the top of the 12-foot pole down to the ground, right? So there's some sort of stake in the ground. So we'll call this length right here y. And then from this stake up to the top of the 28-foot pole, we'll call that length z. So the total amount of wire will be equal to y plus z. So we know these poles are 30 feet away from one another. And let's go ahead and look at this 12-foot pole. So if we place our stake somewhere right here and we look at the 12-foot pole, well, this stake, well, let's just call that x units away from the 12-foot pole, right? So I'm going to use this variable x. So if this stake is x units away from the 12-foot pole, well, from here to the 28-foot pole is going to be 30 minus x, right? So whatever this distance is, because the entire distance is 30, so from here to here will be 30 minus x. Now I'm doing this because we're going to use the Pythagorean theorem. Again, that's a squared plus b squared to construct an equation. Right here we have w is equal to y plus z, but I don't want to use y and z. What I want to use is x's, all right? So I want to use these x's so we have one equation in one variable, all right? So this is the kind of algebra we need to kind of do. In order to do this, again, we're going to be using the Pythagorean theorem, but you can see our triangles right here. We have x, y, and 12, and then right here we have 30 minus x and 28 and z. So now we're going to figure out how to write y and z, these lengths right here, in terms of x. So let's see this algebra right now. And again, if you don't understand anything, just kind of continue on with the video. So here is our model. Now we are thinking about the Pythagorean theorem again, right? So in other words, this squared plus this squared is equal to this squared right here, because these are right triangles. So x squared plus 12 squared is equal to y squared. And then over here, 30 minus x squared plus 28 squared is equal to z squared. Let me kind of scroll up here. So all we're doing is using the Pythagorean theorem. So now let's go ahead and solve for these respective variables, y and z. So to solve for y, all I have to do is take the square root of both sides of the equation. So y is equal to the square root of x squared plus 144, and z is equal to the square root of x squared minus 60x plus 1684. Now I'm going to show you the algebra here on this one. This is actually pretty easy to see, but some of you might be a bit confused on how I went from here to here, and I'm going to show you this now. So to solve for z here, what we need to do is take this 30 minus x squared and actually multiply 30 minus x by itself. So here is 30 minus x times 30 minus x. Now we have 30 minus x squared plus 28 squared is equal to z squared. So 28 squared is 784 and z squared is z squared. Okay, so now let's go ahead and focus in on how to multiply 30 minus x times 30 minus x. And what I'm showing you here is stuff that is like at the first year algebra level. So as I indicated in the beginning of this video, as long as you have some pretty good basic algebra skills, you should understand most of the solution. So we're going to use the FOIL technique, first, outer, inner, last, to get the product here. So the first is going to be 30 times 30. Then the first outer will be 30 times x, and the inner will be x times 30, and then the last is going to be x times x. So let's go ahead and do all that right now. So 30 times 30 is 900. 30 times x is negative 30x. Then we have negative x times 30. That's another negative 30x. And then a negative x times a negative x, a negative times a negative is a positive, and that's positive x squared. So the product of all of this is this, but we can't forget about the rest of this, right? So we have 784. So now all of this is equal to z squared. So we can combine like terms here, and when we do that, we're going to get the following: x squared minus 60x plus 1684, and this is equal to z squared. So to solve for z, we are going to take the square root of both sides of the equation, right? So z is equal to the square root of x squared minus 60x plus 1684. Okay, so hopefully that makes sense. And now let's go back to our figure. So remember, we have this formula right here, or this equation. So the wire, right, the total amount of wire here is y plus z, but we just solved for y and z in terms of the variable x. So let's go ahead and take a look at that right now. So again, y is equal to the square root of x squared plus 144, and z is equal to the square root of x squared minus 60x plus 1684. So if we add these two together, this will be the amount of wire in this formula. So again, the wire is equal to y plus z, right? This distance plus this distance. But we just solve for these variables in terms of x because we want to replace this y and this z with something that has the x variable in it. So we have one equation with one variable. This is really important. So let's do that right now. So w is equal to y plus z. Again, we solve for y. It was equal to the square root of x squared plus 144, and z was equal to the square root of x squared minus 60x plus 1684. Now we need to place a restriction on x. So x has to be greater than or equal to 0, but less than or equal to 30. Now, why is this? All right, so our final answer has to be between this range because if we go back up here, remember, our poles here are 30 feet away. So this distance x can be right here, but it can't be negative. So it can be 0 or it can be up to 30 feet away, but it can't be more than 30 feet away. So this is a very important restriction to note. So now we're going to have this one equation for the amount of wire in one variable. And this is really important. So the amount of wire is this expression right here. Now, just in case you don't know, you can rewrite this expression. The square root of something is the same thing as taking it to the 1/2 power. So if you have the square root of 5, that is equal to 5 to the 1/2 power. So instead of using these radicals, these square root symbols, we're going to express this formula this way, right? So all of this to the 1/2 power plus all of this to the 1/2 power. And you're going to see why here in just one second as we get into the calculus. So this is where the calculus part of this video or this solution starts. So we have this formula for the amount of wire. And what we want to do is minimize the amount of wires. So what we're going to see next is something called the first derivative. We're going to find the derivative of this function right here. Now this is going to be a decent amount of algebra, but I'll show you all this algebra in just one second, but I just want you to kind of see the big picture. So we have one equation in one variable x, and we're going to find something called the first derivative. Now, the first derivative, okay, is extremely important because this will help us minimize or maximize something that we are interested in. Now, we want to minimize the amount of wire, so we need to find, again, the first derivative, and this involves using calculus. So I'm going to show you the answer here in terms of what is the derivative of all of this. So I'm going to show you the answer, and then I'm going to show you the steps on how to find the derivative. So basically, to find the derivative of functions in calculus, you just simply follow a lot of different rules. So if you know algebra, you'll be able to follow these rules. And there is a lot of rules, but again, it's basically just following a simple procedure or a recipe. So here is the derivative of all of this, and we're talking about the first derivative. And in algebra speak, if you will, that is dw over dx, or we're going to find the derivative of this with respect to the variable x. All right, so we're finding dw over dx. Now there's another way to write this. You can write this as y prime. But if you've ever seen anything like this in terms of calculus notation, we're talking about, again, the first derivative. So here is the answer. So when you take the first derivative of all of that, here is the solution. So again, we have a lot of algebra here, but let me go ahead and explain how we went from this, all of this stuff right here, to our solution, because I don't want any of you out there that don't understand calculus to know what's going on. All right, so here is how this works. So here is our function right here. We have x squared plus 144 to the 1/2 power. Remember, this is the same thing as the square root symbol, plus x squared minus 60x plus 164 to the 1/2 power. So this is what w is equal to. So we're going to take the first derivative of this function. So in this particular case, we're going to follow this calculus rule. And what we're going to do is take the power 1/2. We're going to focus in on this part first, and then we'll do this part second. So we're going to take this 1/2 and multiply it by whatever number is in front of this parenthesis. So that's just 1. So 1/2 times 1 is 1/2. All right, so it's not that difficult in terms of the steps. Now what we're going to do is subtract a 1 from whatever power this is. So 1/2 minus 1, we'll figure that out. Of course, that is going to be equal to negative 1/2, right? So we're talking about basic math here, but we're not done because we have some stuff inside of the parentheses, and we need to do the same thing here. So we're going to do the same rule. We're going to take this 2, and we're going to multiply by this x. So 2 times that x, or 1x, is 2x. And then we'll drop that x down. 2 minus 1, of course, that is 1. So that'll be 2x to the first power. So 2 minus 1. Now, if you're confused, again, what we're going to do is take this exponent, multiply by this coefficient. So 1/2 times 1, that's 1/2. And then we're going to subtract 1 from it. Okay, once we're done with that, we have to go inside of the parentheses here and do the same thing to any function that is inside of the parentheses. So we'll take this 2, multiply by this 1. We get 2 times x, and our x is going to be decreased by 1 up here, the exponent. So that 2 minus 1 is 1. So we're going to multiply the result of this by the what we got inside of the parentheses. So that, again, that's going to be 2x. So if you don't quite understand this, you'll definitely learn this if you take an actual calculus course, but these rules are not that difficult. So now you might be asking, what about this 144? Well, when we take the derivative of a number like this, a constant, it's just 0. So this is what we have. Now we need to use our algebra skills to clean this up. So 2x times 1/2 is x, right? So it's going to be this times this. All this right here is one product, right? So 1/2 times all of this times this. So 2x times 1/2, or 1/2 of 2x, is x. And now we have x squared plus 144. 1/2 minus 1 is what? That's negative 1/2. Now, if you don't know, let me just go ahead and show you a little algebra here. If you have x to the negative 1, anytime you have a negative exponent, you can write this, matter of fact, let me do this differently. Let me use x to the negative 2 power. So we're talking again about basic algebra. So to write this, to get rid of this negative exponent, you can just go 1 over x squared, right? So if we move this power down into the opposite side of the fraction bar, in this case it's the denominator, the sign becomes the opposite. So in this case it will become positive. So here what we have is x times all of this, x squared plus 144 to the negative 1/2. So just like with this basic algebra rule, we're going to write this negative 1/2 as a positive 1/2. But remember, a positive 1/2 is the same thing as the square root. Okay, so I could write all of this as x times x squared plus 144 to a positive 1/2, or the square root of x squared plus 144. So this is how we find the first part of this derivative. I know this is a lot of work, but we're going to do the same thing right here. So let's go ahead and continue finding the first derivative. We only did the first part, and now let's use the same procedure here to find the rest of the derivative. Okay, so here is that part. So we're going to take this 1/2 again and multiply by what's in front of this. So that's a 1. 1/2 times that is 1/2. So now we're going to drop that exponent by 1. So inside we have x squared minus 60x plus 1684. So we're going to take the derivative of this. This is going to be 2 times this 1. So that's 2x. And we're going to drop this down by 1. All right, just like we did right here. Now we're not done here because we have to continue on and we have a 60x. So this x is actually x to the first. So now we have 1 times negative 60 is negative 60. And then when we subtract 1 from this variable, we're going to get x to the 1 minus 1 or x to the 0. Anything to the 0 power is 1. So this just becomes 60. So now we have 1/2 times all of this times 2x minus 60. So let me erase this here so you can see what's going on. And you can kind of rewind the video here if you don't totally understand this. Again, I don't expect all of you out here watching this video to get every single step, especially, when we're figuring out what the first derivative is. But if you have pretty good algebra skills, you should see what's going on algebraically. But believe me when I tell you, if you know algebra, you can do calculus. So what we're going to do right here, we have 2x minus 60. Let's factor out the 2. So now we have 2 times x minus 30. So now we can take this 2 and multiply by this 1/2. So that'll just be 1. So our final answer here, again, is going to be this x minus 30. This is going to be in the numerator. We have this negative exponent. So remember, this is going to drop down into the denominator. And we can write this as this to the positive 1/2. Or we can just get rid of that 1/2 and put back that square root symbol. Now we're going to talk about why this is so important. What is the derivative? What is it conceptually? Because this is where we're going to figure out the solution to this problem. All right, so let's talk about why the derivative is so important. And this is where calculus becomes extremely powerful. So we can take this entire thing right here and put it into our graphing calculator, or we can manually graph this. This will be a lot of work, but if we had a computer or a graphing calculator, we could see the graph of this function right here. But let's just, for a simplistic example, let's just say it looks something like this. So the derivative of this function, the first derivative. Now notice here again, this is all in x, right? So this entire equation has the variable x, and we have dw dx. Now, the way to think about the first derivative in calculus is the derivative tells us the slope along this function at any point. So in other words, again, we're talking about basic algebra. So let's take this point right here. Let's suppose this little yellow curve, it represents some portion of this graph. Okay, so let's suppose at this point we want to know the slope along this function or along this curve. Well, the slope would be this tangent line. It would be something like this. Now, as we kind of go through this curve, the slope is going to change. So maybe like right here, the slope becomes like this. Over here, the slope is this way. Okay, so what we are interested in is where is the slope 0? Okay, where is the slope 0? So for those of you that forgot your algebra, the slope, okay, is defined as the rise over the run. So it's positive in this direction, it's negative in this direction, and it's 0 when we have a horizontal line. Now let me get rid of all this stuff right here and kind of take a look at the big picture. Okay, now the big picture is that this function is what? Well, this represents the length of the wire, right? Now, of course, this is the derivative of that, but we're talking about the length of the wire. And what we want to do is minimize the length. So we can just think of this graphically, okay, where this graph effectively is describing or telling us the length of the wire in different locations. Okay, hopefully that kind of makes sense. But if we can look for this point right here, this is the minimum amount. Okay, now the minimum or maximum amount will always occur when the slope is equal to 0. Okay, so if we can determine what point x is where the slope is going to be 0, and of course that means that if we can find the first derivative and set it equal to 0, what we're doing is finding that x location where the slope is 0, and that is the very bottom. That is the minimum, and that means this is the minimum amount of wire, right? Because we're talking about this w function that represents the amount of wire. And of course, we express that in terms of x. So this is what we want to do. We want to set this entire thing equal to 0 and solve for x, and that will tell us the minimum amount of wire to use. So now we're going to have a lot of algebra fun, and what we're going to do is set our first derivative equal to 0, and of course we know that the first derivative is all of this. We're going to set it equal to 0 and solve for x. So you got to have very strong algebra skills, and I'm going to go through this somewhat quickly because I know this video is lengthy, but hopefully the solution here will give you an appreciation of how strong in algebra you really need to be successful in calculus. Okay, so we're going to take this entire thing, set it equal to 0. Again, this is our first derivative, and then we're going to solve for x, and that will be the answer to the problem. So let's go ahead and start right now. So this is equal to 0. So I'm going to take this entire thing and move it to the other side of the equation. So that means I have to subtract it from both sides. So now I have this right here is equal to negative of this. Now you can pause the video if you want to get into the details. Now we have to be careful here because this negative is the same thing as a negative sign in front of this expression right here. So I can write this as plus negative like so, and that negative sign will go to the numerator. So now I have like a negative 1. So this becomes negative x, and negative 1 times this negative 30 becomes a positive 30. So this expression right here is going to turn into 30 minus x. So you're going to see that right now. So we're going to go from x minus 30 to 30 minus x right now. So there you go. And now we have effectively a proportion. So we have this fraction is equal to this fraction, and we can use the cross product. In other words, we just cross multiply to get rid of these fractions. So x times this is going to be this, and then we have 30 minus x times this, right? So we have 30 minus x times the square root of x squared plus 144. So I'm just kind of saying this, and not to keep repeating this entire expression. Okay, so if you understand, the problem or the solution so far, then we're in good shape. So here we have 2 square roots on either side of the equation. So what we need to do to get rid of these radicals is square both sides. Now there's even some additional algebra steps that I'm not showing, but it's really not important in terms of fully, just kind of getting a sense of how to solve this problem. And I'll explain that step or those missing steps in just 1 second. But we're going to square both sides of the equation. So when I square this side, this square root goes away, right? So anytime you square a square root, it goes away. And then when I square this, I'm going to end up with x squared. So I have x squared times this, right? The square root went away over here. And then when we square this side of the equation, we're going to get 30 minus x squared. And then over here, the square root goes away on x squared plus 144. So again, if you don't really kind of understand the algebra, just pause the video or rewind it a bit. If you got, again, good algebra skills, this will make sense. But I am covering a lot of stuff rather quickly. Okay, so now we're going to have to do a bunch of multiplication here and construct some pretty big polynomials. So let's do that right now. So this x squared, we're going to multiply into this trinomial. So this would be x squared times x squared, that's x to the fourth. X squared times negative 60x, that is going to be negative 60x cubed. And then x squared times 1684 is 1684x squared. So we're going to do the same thing over here. But this is a lot of algebra that I'm not going to just show you. I don't want to make this video too long. I know it's already pretty lengthy right now, but again, this is what you have to do in calculus. So here we have to take 30 minus x squared. We have to multiply it by itself. Okay, just for those of you that want to do this, get that answer. And then we're going to take that and multiply it by x squared plus 144. All right, so if you know algebra, you'll be able to do this successfully. But if you want to try that, here is what you're going to get. You're going to get x to the fourth minus 60x cubed plus 1044x squared minus 8640x plus 129,600. All right, so again, this is a lot of stuff. Now, this is the left-hand side of the equation, right? We are trying to solve an equation here, so I don't want you to get lost in this algebra. So the left-hand side is this, and the right-hand side is this big expression right here. But now we can clean up this equation because we have, for example, we have an x to the fourth on the left-hand side, and we have an x to the fourth on the right-hand side. So these things are going to go away if I subtract x to the fourth from both sides of the equation. They just kind of cross cancel. So a lot of these terms are going to go away. So when we clean up this gigantic polynomial, we're going to get this, right? So here's the actual polynomial. So when we clean this up, again, we're talking about basic algebra. So we can get rid of the x to the fourth. We can get rid of the negative 60x cubed, etc., etc. So we're left with this right here. So we have 640, excuse me, if I misspoke, I apologize, 640x squared plus 8640x minus 129,600. Okay, so again, a lot of numbers and terms, and I apologize if I misspoke. The numbers are right, so if I said something incorrectly, I apologize. But again, everything that's written down in this video is correct. Okay, so now what we have is a gigantic quadratic equation. We're talking about, basic algebra here. Well, we've got a first year algebra. So we have 640, 8640, and 129,600. So we can factor out the greatest common factor. That happens to be 320. And when we do this algebra, you're going to end up with a trinomial that we can factor into this, x minus 9 times 2x plus 45. So if you take this and we multiply it by this, and then we multiply it by 320, we're going to get back to this quadratic equation right here. So we're just exercising in those skills that you learn in first year algebra, but of course, this is a lot of work. So now we can get rid of this 320 because this is equal to 0. So if we divide both sides of the equation by 320, okay, the 320 goes away because 320 divided by 320 is 1, and 0 divided by 320 is 0. So here again we have x minus 9 times 2x plus 45 is equal to 0. So this is what this equation finally distills down to. So now to solve for x, we're going to set each factor equal to 0 and solve. So we have x minus 9 is equal to 0, so x will be equal to 9. And then here I can set 2x plus 45 is equal to 0. So when we do this algebra, x is equal to negative 22.5. Now we are almost done. But the step that I'm not showing you here is that anytime you square both sides of an equation at this point right here, you could get extraneous solutions. So what you need to do is actually check these solutions. I'm not going to show you that work because that's really a lot of additional work, but it's something that you would have to do. But here are our two solutions. So what is x? Remember, x is the distance away from the pole, that 12-foot pole, right? So we have x is equal to 9, and we have x is equal to negative 22.5. But remember, x has to be between 30 and 0, okay, because we set that restriction. So this is a negative number. We can throw this answer away. So x is equal to 9. So that means the final answer here is that to get the least amount of wire to make this connection between these two poles, remember x represents the distance away from the 12-foot pole. So to get the minimum amount of wire, you need to be 9 feet away from the base of the 12-foot pole. This is where we have to put our stake in the ground in order to have the least amount of wire to run from the top of this pole down to the ground, back up to this pole right here. So I hope you enjoyed this video, and I apologize for its length, but this is an actual calculus problem. So if you were ever wondering about the amount of work or how much mathematics you need to know in order to, do well in calculus, you have to have very strong algebra skills, geometry skills. So I'm going to leave links to some courses in the description of this video. If you are getting ready for calculus, you definitely want to do well in pre-calculus. You'll find that link in the description of this video. But hopefully this inspired you to continue to learn math. Calculus is so awesome, and hopefully I did a pretty good job, getting you excited about the subject. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time, and have a great day.